All right, so I'm actually gonna record this video to give you a brief review of what you're gonna see on the quiz on Friday, and also go over the two examples that I did in class today. So what I'm gonna do is actually I'm sharing my whiteboard, and so what are you gonna see on tomorrow's quiz? Well, first of all, the sections that are coming on Friday's quiz, are sections 1.1 and 1.2, and one of the parts that you're gonna see on your quiz is identifying a set of numbers. So I'm going to give you a couple of numbers, and then I'm going to give you a couple of properties and things that we're going to see. And hopefully you guys will be good. Okay. So real quick, let's say I give you a set of numbers like -1, 4, the square root of 2. What if I give you pi, the number pi? Pardon my pi symbol. What if I give you a number like, I don't know, 0.5 and something like 1.33, and we'll keep repeating, and we'll just do the little line that indicates that that's a repeating decimal. So what if I give you these numbers, right? And let me write the commas next to them. Hopefully I can do that. All right. Okay. So what if I give you 1, -1, 4, the square root of 2, 0.5, and 1.33? Now, I want you to classify them as either rational numbers, irrational numbers, natural numbers, or integers. So let's start with -1. -1 can be classified as an integer, and more specifically, a negative integer. Now, uh, technically 4 can also be considered an integer, but just for quiz purposes, we're going to call it a natural number. Although integer does refer to any positive or negative number. But for class purposes, we'll go ahead and say that 4 is a natural number. And what I mean by natural number is a number that you can count. It's a number that you can count in nature. And natural numbers only include positive integers, because I can't count -1 tree. It's either one tree or no tree. Um, so that's why natural numbers are, you know, uh, nor are all positive integers. And integers can include positive numbers or negative numbers, but just for this video's purposes, we're only going to include them, or say that -1 is just a negative integer. Now, if we have to talk about rational numbers, well, rational numbers are basically, and I forgot to write that down here. Let's see if I can write a fraction, right? Let's see if I can write a fraction down here. We'll say, I don't know, 5/6 or something like that. So 5/6 and 5/6. Okay. And rational numbers are pretty much any number that I can either express as a fraction, or that are terminating decimals or repeating decimals. So our rational numbers in this case would be um, well, 5/6 or 5/6. My rational numbers would be 0.5 because it's a terminating decimal. Yes. And I can also say 1.33 is a rational number because it has a repeating decimal. So remember, both um, both terminating decimals, like the case of 0.5, and repeating decimals, like the case of 1.33, are rational numbers. Now, so is a fraction. So 5/6. I know it doesn't look like the same way I drew it here, but that slash just it's also used to represent a fraction. So 5/6 is also a rational number. Okay, so the last type of number that we discussed in class are irrational numbers. Now, irrational numbers are basically numbers that are not repeating decimals or numbers that are not terminating decimals. So, for example, the square root of 2 is irrational. And it's because if you were to calculate the square root of 2, you get approximately 1.41, because the reality is that the square root of 2 is not a repeating or terminating decimal. So that's an example of a irrational number. Okay, so let me go ahead and write that down here. Okay, so the square root of 2 is an example of an irrational number. Pardon me for the 2. We also have pi as an irrational number, because pi is actually approximated to 3.14159. But the reality is that pi is an infinite decimal. It is not a terminating decimal. It is not a repeating decimal. So you're going to see a part like that on Friday's quiz. Another part that you'll probably have on Friday is where you have to identify the properties. So if I say something like 7 plus 3, 7 plus 3 is equal to 3 plus 7, that's a property, and that is the commutative property. And I'm actually just going to write a C next to it, okay? It's a commutative because it's basically telling me that whether I have 7 plus 3 or 3 plus 7, I'm going to get the same thing. The same is true if you have something like 2 times 4 is equal to 4 times 2. And that's also the commutative property, okay? The associative property is where you have numbers, more than 3 numbers, or 3 or more numbers. Generally, is 3 or more numbers, although it's not necessarily subjected to that. But generally, if I have something like 3 plus, I don't know, 2 plus 7 equals 7 plus hopefully that will look better. 7 plus 2 plus 3. And it's associative because basically what I'm doing is I'm rearranging the numbers. So one thing that needs to be pointed out about the commutative and associative properties specifically is that they're pretty much the same property for adding and subtract and multiplying, excuse me. So the associative property also applies to multiplication. And again, you can go to, I think it's page 3 in your textbooks, where they have all these properties lined up. What if I have something like 3 plus 0? And of course, 3 plus 0 equals 3. So what if I have that? 3 plus 0 equals 3. So if I have something like 3 plus 0 equals 3, this is the identity property. But the identity property of addition, okay? And the identity property of multiplication would be if I have -1 times, well, actually, yeah, let's just use -1. I already wrote it. Times, 1. If I have -1 times 1. If I have -1 times 1, of course, that equals -1. So that would be the identity property, but of multiplication. Okay, so the identity property of addition is basically telling me that anything added to 0 is, the same number, and that anything multiplied by 1 is the same number. We have other properties like the inverse. So what if I have something like 5 times 1/5? If I have something like 5 times 1/5, and that equals 1, that equals 1. Well, that's the inverse property of multiplication. Okay, now I'm not going to use I. I'm actually going to use IN to abbreviate it just so we don't confuse it with the identity. Of course, on the quiz, you're going to write the word, but basically 5 times 1 is 5, and 5 divided by 5 is 1, so that's the inverse property of multiplication. Now, what would the inverse property of addition look like? Well, let's say we have 3 again, and I'm using 3 a lot today. 3 plus, and we'll say negative 3. 3 plus negative 3, and that equals 0. So the inverse property of addition says that any number added to its inverse is going to equal 0. So any number, like if I have, and that would work with any number. I could write 1,000,000, and 1,000,000 plus negative 1,000,000 is going to equal 0. So that property is pretty much straightforward. And always remember in algebra that the opposite of adding is multiplying. So, for example, the opposite of adding is multiplying means that if I have 5 minus 3, which I know is going to equal 2, if I add 5 plus negative 3, I'm going to get the exact same answer. So that would be, both of these problems would equal 2. So the opposite of subtracting, or the opposite of adding, is subtracting, or the opposite of subtracting is adding, however you guys want to say it. But what I want you to understand is that if I have 5 minus 3, that's actually the same thing as saying 5 plus negative 3. And the other part, or the other thing that we went over in class, was actually evaluating expressions. So if I give you an expression like 3x squared plus or minus, I don't know, 4, and we're going to say x equals negative 1. I want you to evaluate that. So when you're evaluating an expression, the first thing that you need to understand is that the value of the variable must be given to you. If it's not given to you, then you can't evaluate it. In that case, you'd have to solve as if it were an equation. So that's the first thing. And I'm already giving you the value of x. I'm saying that x equals negative 1. So I would simply change that to 3 times negative 1 squared. Okay, now the rules of order of operation, or PEMDAS, are extremely important for you guys to remember, because when you're solving these exercises, especially evaluating expressions, that could be tricky. So the order of operations says I'm going to work with my parentheses. So negative 1 squared is the same thing as saying negative 1 times negative 1, and that would be positive 1. So that's going to be 3 times 1 minus 4. And that's pretty easy. It's pretty straightforward. I'm pretty sure that as you're watching this, a lot of you already know the answer. So you're thinking faster than I can write on this thing. So 3 times 1 is 3. And 3 minus 4 is negative 1. 3 minus 4 equals negative 1. And that is your answer, guys. Okay? So 3 minus 4 is negative 1. And that's it for that exercise. Now, the last thing you're going to see on the quiz, and then I'm going to move on to today's class, is simplifying expressions. And what if you have something like 3x squared, and I've really used 3 a lot today, plus, I don't know, plus 8. Let's see if I can do 8 on this thing. And there's my 8. 3, sort of. 3, and they'll say minus 5x, or 5 times, we'll do that, x squared plus 2. So what we're going to do is, first of all, we're going to leave this side completely intact because there's nothing I can do with it yet. I cannot add 3x squared and I cannot add a because they're not like terms. So I'm actually going to just leave them expressed as 3x squared plus 8. And what I'm going to do here is bring down the minus sign, and I'm going to multiply. So minus 5 times x squared is minus 5x squared. Minus 5x squared. And then minus 5 times 2 is minus 10. And then I'm just going to combine my like terms. So 3x squared is going to go with 5x squared, and I'm going to subtract that. And again, it's normally this is a process you can do mentally, but for quiz purposes, and I am asking you guys to show me the work so that way I can evaluate your exams. So 5x squared and minus 5x squared. And of course, if I subtract this, this would be negative 2x squared. So let me just go ahead and write the answer down. And you're going to just do the same thing. So you have plus 8 minus 10. Now, plus 8 minus 10 is the same thing as saying positive 8 plus negative 10. Okay, so plus 8. I should have chosen an easier number to write on this thing. Plus 8 minus 10. So plus 8 minus 10 is negative 2. So that means that the answer for that problem is 2x squared minus 2. So again, you can review a lot of these concepts on section 1.1 and section 1.2. Also, the homework assignments that we discussed in class and all that stuff we can use again. And there's also some extra practice problems on page 61 and 62. Now to today's class. So today's class, you guys had to pretty much just rewrite formulas. And we did 2 examples. One was the circumference formula. And the circumference formula, which again, the circumference is kind of like calculating the perimeter of a circle. If a circle had corners, it'd be the equivalency of it, but it's not, just for the record. C equals 2 times pi times r. So this is an example 1 on page 26. Let me see if I can do that pi symbol a little better. That one looks better. Where r is the radius, okay? So on page 26, they're asking us to solve for r. So we're going to solve for r. For r. Now, how do we solve for r? When I mean solve for r is I want to leave it alone. Now, here's the thing. When you're solving for r, that means that I have to get rid of the 2 pi. So how do I get rid of the 2 pi? Well, the circumference formula says 2 times pi times r. So that means that I'm multiplying 2 pi. So to get rid of the 2 pi, I'm going to do the opposite of multiplying, which is dividing. And I'm going to divide my entire equation on both sides by 2 pi. So divide by 2 pi on both sides. So this side cancels out. And now I have r equals c divided by 2 times pi, or 2 pi. So the second part of that problem says find a circumference if r equals, or excuse me, find radius if c equals 44. 44 inches, to be exact, is what the book says. 44 inches. 44 inches. So what that means is that I'm just going to substitute the value of 44 where the pi is, and where the c is, excuse me. So you're going to say 44 over 2 times pi. Now, you obviously need a calculator for this exercise. And of course, this is c equals, or I'm sorry, not c, r equals. Let me erase that. R equals. I'm sorry. I'm trying to get rid of that. Okay. So R equals, sorry, R equals 44 divided by 2 pi. So in your calculators, you multiply 2 times pi, and the result of that you divide by 44. So I'm going to actually approximate the answer. So 2 times pi is approximately 6.28. 28 and 44, you divide by 6.28, and that is approximately 7. approximately 7. Okay, so again, that is the first example that we saw on page 26. I'm actually going to go ahead and do the last example that we saw, which was on page 27. And then that would be the end of this video. So the last example says that the perimeter of a rectangle equals 2 times the length, or 2L, plus 2 times the width, or 2W. Okay, so the first thing is they want us to solve for W. For Okay, give me 1 second. Technology sometimes decides not to cooperate. Whoops. So we're going to solve for Okay, so I'm going to try to write it down. If not, solve for W. This is example number 2 on page 27. I apologize for the inconvenience. So solve for W. If I'm going to solve for W, which is, this is a mutant W right here, so I want to leave that alone. Let's see if I can fix that. See if I can fix that and erase it. Much better. So if I'm going to solve for W, that means I have to get rid of this. Now there's a plus sign between 2L and 2W. So if I want to isolate the W, I have to get rid of the 2L. So that's why I subtract 2L on both sides first. So this is 2L. And we do the same thing here. Minus 2L. So this is going to cancel out. And that's going to leave me with P minus 2L equals 2W. But I still need to solve for W, so that means now I have to get rid of the 2. Now I can do it because, first of all, 2 is being multiplied by W, and secondly, because there's an equal sign between 2L and 2W. Had there been a plus sign or a minus sign, I can do this. And a lot of students make this mistake. Okay, you cannot divide if there's a plus sign. Like if there's a plus sign between these two terms, I can't divide that. I can only divide them when there's an equal sign if one of them is a multiplication. So I divide by 2 on both sides, and that includes everything here will be divided by 2. And of course, this cancels out. And now my formula, or my new formula, is W equals P minus 2L divided by 2. So The other part of the problem says, well, now that you found the width, now I want you to tell me what would, or now that you solved for W, I want you to tell me what would the width be if the perimeter, or P, equaled 44 and L equals 12. So this is actually much easier because now that I know the values of P and L, it's just plugging in and evaluating, which even though this section is not coming on your quiz, is something that you already know how to do. So I'm going to find W. I'm still looking for W, but here we go again. But now P is going to equal 44, so I substitute that by for 44. And L is 12, so that would be 2 times 12. So 2 times 12. And of course, all that divided by 2. So now we know that 2 times 12 is 44. So let's see if I can move this bar a little bit over. So let's see if I have some space here. So W equals 44. So 2 times 12 is 24. So that'd be 44 minus 24. Actually, I used 44, but I think the number in your book was different, but that's all right. It's going to be the same answer regardless. Over, or excuse me, it's the same process regardless of the number. So I think I made a mistake, but that's okay. So anyway, so we have 44 minus 2 times 12, which is 24, and that's going to equal 20, and 20 over 2 is 10. Okay, so let me see. 44 minus 24 equals 20. And 20 over 2 equals 10. So in the corner right here, W equals 10. 10. W equals 10. And this is, of course, the answer to the second part of the problem. I know it looks kind of smushed together. I'm sorry for that. But if you do have any questions, you know where to find me. Hopefully, this mini review for the quiz and a review of the class will be helpful. So stay safe, and until we see each other in our next class. Bye-bye.